Hi. In this video, we are going to see about equalization techniques in wireless communication. So, introduction. Equalization in wireless communication is a crucial signal processing technique used to compact the intersymbol interference and improve signal reception quality at the receiver. It aims to counteract the distortions introduced by the wireless channel, such as multipath propagation and frequency selective fading, which can lead to signal degradation and bit errors. Equalization is implemented as a signal processing block in the receiver, and it can be either linear or nonlinear. Three techniques are used independently to improve receiver quality. First one is equalization and second one is diversity. Diversity techniques in wireless communication are methods used to improve the reliability and performance of wireless links by providing multiple independent signal paths. These techniques exploit the random nature of radio propagation to combat fading, which occurs when signal is weak or distorted due to obstacle and interference. The diversity is implemented by using two or more receiving antennas. It reduces the depth and duration of the fades. So, introduction. The channel coding improves mobile communication link performance by adding redundant data bits in the transmitted message. Channel coding in wireless communication is also used to enhance reliability by mitigating errors introduced by the wireless channels by adding redundant data bits. It's crucial for ensuring the integrity of information transmission in the presence of noise, interference, and fading. Equalization techniques. The term equalization can be used to describe any signal processing operation that minimizes ISI. It is a technique that compacts distortion caused by the channel, particularly intersymbol interference, to improve signal quality. It works by reversing the effects of the channel on the transmitted signal, essentially making the frequency response flat. Equalization techniques can be broadly categorized into linear and nonlinear. Equalization aims to overcome the channel impairments such as ISI and fading. It also improves the reliability and performance of wireless communication systems. In essence, equalization techniques are essential for ensuring reliable communication in wireless channel by compensating for the impairments introduced by the propagation medium, allowing for more robust and efficient transmission of data. Two operation modes is used in equalization techniques. First one is training and second one is tracking. A known fixed length training sequence is sent by the transmitter to the receiver. The training sequence is typically a pseudo-random signal which is in fixed length. Immediately following the training sequence, the user sends the data. Adaptive equalization. Adaptive equalization is a technique used in digital communication systems to compensate for signal distortion caused by the communication channel, particularly ISI. It involves a filter that automatically adjusts its characteristics to adapt to changing channel conditions such as time varying properties or multipath propagation. This self-adjustment helps to minimize the effect of ISI and improve the reliability of data transmission. Adaptive equalizers are designed to adapt to these time varying channel conditions. The adaptive equalizer at the receiver utilizes a recursive algorithm to evaluate the channel condition. As a consequence, the adaptive equalizer is continuously changing its filter characteristics over time. Activity. Three factors affecting the time spanning over which an equalizer converges. First one is equalizer algorithm, second one is equalizer structure, and third one is time rate of changing of the multipath radio channel. This is the block diagram of a simplified communication system using an adaptive equalizer at the receiver side. Adaptive equalization derivation involves designing a filter whose coefficients adapt over time to counteract the effects of a changing communication channel, aiming to minimize intersymbol interference and noise. This is achieved by iteratively adjusting the filter coefficients based on the errors between the received signal and the desired output, often using algorithms like least mean squares or recursive least squares algorithms. The output of the equalizer is given in this equation. So in training phase, some cases a training sequence, that is a known signal, is transmitted to help the equalizer initially estimate the channel characteristics. In tracking phase, the equalizer continuously monitors the channel and adjusts its coefficients to track changes in the channel characteristics. The desired output of the equalizer is given in this slide. If the channel is a frequency selective, the equalizer enhances the frequency components with small amplitudes and attenuates the strong frequencies in the received frequency response. The basic structure of adaptive equalizer is given in this slide. A basic linear equalizer during training phase. So a basic adaptive equalizer structure typically involves a transversal filter with adjustable weights, an error calculation mechanism, and an adaptive algorithm. The filter, often a tapped delay line, processes the received signal, and its weights are modified iteratively by an algorithm like LMS or RLS based on the error between the equalizer output and a desired signal. This iterative process aims to minimize the error and compensate for channel distortion. So in transversal filter, tapped delay line is used. The core of the equalizer is a tapped delay line where each tap represents a delay of the received signal. Each tap is associated with a weight which determines how much the delayed signal contributes to equalizer's output. The error calculation portion is done and its aim is to produce an output that resembles a desired signal, which can be a replica of the transmitted signal or a specific reference signal. The difference between the equalizer output and the desired signal is calculated, representing the error. The error signal is given in this equation. Assessment. Thank you.